Okay, so here, let's get going on the solar system. So here we go. So when I'm talking to kids, I said, my very enthusiastic mother just sat upon Neptune. That's what we remember, the mnemonic we remember. So my first planet is? Earth. Come on, kids. Mercury, of course. And the next one? Venus. And next, your favorite? Earth. That's right. Next? Mars. And then Jumbo Jupiter and Saturn. And then this next one, when I'm talking to kids, I pronounce it Uranus. Okay? And I've heard it pronounced Uranus. And of course, Uranus. We've gone back and forth. This is the only one named after a Greek god. The others are all named after Roman gods. Okay, and then the last one? Neptune, right? You were going to hang on to Pluto, aren't you? Okay, our solar system is actually very flat. They're very close to the orbital plane, the equator of the sun. And so if we were on Neptune looking straight towards the sun, it looks very flat. Okay, so let's start with Mercury, named after the fake god of speed. Behold, I come quickly, and my reward is with me. Our God is the fastest God in the universe. I picture when he comes back, it's going to be boom. He says, like lightning. He's going to flash, and he's there. He's so fast. In fact, before a word is on my tongue, behold, Lord, you know it already. Okay, so let's look at Mercury. Who here loves a vacation that is filled with sunshine and peace and quiet, right? That's what we like. Mercury is your place. There is no sound because there's no atmosphere, and it's 800 degrees. Very sunny. It's a little larger but more cratered than our moon, and these colors denote the height. So purple is lowest, you can see the craters, and white is high. So there's some plains, but a lot of craters. Every planet has something the other planets don't have. Mercury has the largest impact crater. So it's almost 1,000 miles across, and here's a close-up of it. Now, here's something that was unique. Messenger went there 2008, and it saw these unique hollows, and they look clean and fresh and young. No other planet has this kind of terrain. In 1984, nuclear physicist Russell Humphreys, strong Christian, predicted Mercury's magnetic field would decrease quickly after 1975 due to his belief in a young solar system. So in 2008, which I love, he's a Christian physicist, and he is very respected in the evolutionary world, which says something about his character. And Messenger did indeed compare the planet's magnetic field with the 1975's reading. It was indeed less. And actually, this made headline news, but probably most of us didn't read this. Planet Mercury has molten core, NASA researchers find. Okay, so what does that mean? Here's what it means that wasn't in the headline. If Mercury is 4.6 billion years old, its core should be solid with a constant, not changing magnetic field. Its fluctuation requires a liquid and young iron core. So Mercury is very young. There's actually a theory that Mercury was formed outside of our solar system and somehow migrated past the giant planets until it started going around the sun. But I mean, that's what the theory had to say to explain about Mercury. It's definitely very young. Venus, named after the fake god of love. Beloved, let us love one another, for love is of God, and everyone that loves is born of God and knows God. Our God is love personified. Now, this is Akatsuki, the Japanese orbiter. This is their image of Venus in infrared, revealing the warmth of the atmosphere on its nocturnal side. Look at the clouds. I mean, isn't that texture just gorgeous? Venus's upper atmosphere whips around the planet every 4 Earth days. It's hurricane force. While it goes around the sun once before the planet rotates once on its axis. So if they're doing shuttles to Venus, sign up for the year shuttle, not the day shuttle, and you will be back before them. Okay, Venus is rotating. This was in National Geographic News. Venus is rotating slower than it was 16 years ago. It is difficult to find a mechanism that will cause the average rotation rate to change this much in only 16 years. Evolution is tiny changes over big time. Venus has big changes, little time. When we measure Venus's rotation, we keep getting different answers. Here's a hydrogeologist in 2018. This was this year. Now look to the right. You see that dark cloud that looks like a bow? Whoops, sorry. The clouds, the atmosphere is whipping around, and that bow cloud is staying still. And that's a kind of a conundrum. They're assuming it might be because there's a part of that Aphrodite Terra, one of the like a plateau on Venus, and they think it's the cloud can't move past the landmass, but yet the atmosphere is going past it. So it has some very interesting dynamics. ESA's Venus Express measured increase in cloud top wind speed from 186 to 249 miles per hour between 2006 to 2012. Again, big change, little time. Here's another one. Thermal imaging showed a red hot spot indicative of a volcanism. When Venus Express arrived in 2006, the spacecraft recorded a significant increase in sulfur dioxide in upper atmosphere, and then there was a sharp decrease. They think there was an eruption on Venus. Okay, the phases of Venus. So here's Earth in the foreground, obviously Sun in the middle, and you can see the phases of Venus are very similar to our moon. So when Galileo studied Venus through a telescope, he observed all of its phases, confirming Copernicus's prediction that Venus revolved around the Sun and not the Earth. Venus actually advanced our knowledge and confirmed we are a heliocentric solar system. Now Venus has a tilt about 3 degrees from our angle of view, so that we rarely see it transiting in front of the face of the Sun. So its last transit was in 2012, and it will not do it again for this century. And that's why. It's typically above or below the Sun. But when it does transit, here's what happened in 1769. Scientists around the world, including James Cook in Tahiti, made detailed measurements of Venus's transit across the Sun, and they triangulated with scientists in other parts of the world where they were able to get the size of the Sun, its distance from Earth, and distances to other planets. So Venus, again, gave us more scientific information about our solar system. See, God knew what he was doing for each of these planets. Because you ever wondered, are they just kind of redundant? Or is there a reason we're in this neighborhood of planets? Who named Earth? You don't know. In the beginning, God created the heavens and the earth. Who named Earth? God named Earth. See, the others are named after mythology, but God named Earth. Even the heavens are the Lord's, but the earth he has given to the children of men. This planet is made for us. We are a carbon-based lifestyle, life force, and we are on the right planet. It is I who made the earth and created man upon it. We were not the result of seeds from aliens or some debris on a comet flying by. He made us upon this earth. He made the earth for us and made us on it. Mars, named after the fake god of war, and there was war in heaven. Michael and his angels fought against the dragon, and the dragon fought with his angels and did not win. Our God is the victor of the greatest battle in the universe over you and me. Okay, Mars, minus 60 below zero in the daytime. It goes to 100 below at night. And I know when they're having discussions about colonizing Mars, does hypothermia enter those conversations? Because this is very, very cold. Phobos. So Mars has 2 moons. It was once believed that they were asteroids that were captured by Mars, but they now know the composition of the moons is identical to the planet. So these are Martian moons. Phobos rises in the west, and it orbits 3 times faster than Mars' rotation. Smaller, slower Deimos rises in the east. Both revolve around Mars at the equator and have raised questions about lunar formation. All right, here's Happy Face Crater, also known as Gal Crater. Greeted our Mars orbiter in 1999. I like to think that an angel said, "Here comes their camera," and he did. You don't like that, huh? So Mars, here's the thin, hazy atmosphere hovers above Happy Face. Gravity is 38% of Earth's, and dust storms last for weeks. And you know we need gravity for our bones. And so 38% gravity up there in Mars. Mars does have some amazing topography. Here's the South Pole. It's believed to be dry ice or frozen carbon dioxide. And it's flat-topped mesas. And here's the North Polar Cap. This is a Chasma Boreal. It's a canyon that reaches into the North Pole. And these walls rise about 4,600 feet. There's a picture. And HiRISE, I think it's still our highest resolution camera out there in the solar system. But isn't that amazing? Okay, these are the layered hills of Arabia Terra. What do they remind you of? Anything? What? Say that again? Amoebas. Oh, amoebas. Oh, okay. I think I said beef. Amoebas, yes. What about those things on the beach? Are they chitons or what's the thing that is it? Oh, yes. Uh-oh. Am I still on? Okay, something just snapped back there, but that's okay. All right, Valles Marineris. This is a canyon. Mars has the largest canyon and the largest volcano. It's 2,500 miles wide, 5 miles deep, and our country, the U.S., is 2,600 miles across. So it would almost go from California to Maine. And then here's Olympus Mons, 16 miles high, and Mount Everest is 5.5 miles. It would cover the state of Arizona. Wow. Isn't that incredible? Okay, there's a lot of sand dunes. If you're signing up for Mars, I think one of you said you want to go to Mars, bring your dune buggy and ice skates. Yes, it stays very cold there. Okay, here's some more dunes, and these aren't with the typical reddish sand that you see for the rest of Mars. These are, Curiosity took these, and they're dark, and that little 2 meters is about 6.5 feet across, and they're about 20 feet high, so they're not very big. Viking 1, when it had this, sent back this image of this face in 1976, thus began the conspiracy theories that NASA was hiding the truth that there were Martians on Mars. So, with our improved technology, they went back and took the picture of that mesa. I mean, it's an 800-foot mesa to show that's what it was. So as Christians, that's something to remember, right? Things are not always as they seem. But then, this image by Spirit revives the rumors that there's Martians. Now, what does this look like? Bigfoot. I call it Lot's... A mermaid. I call it Lot's wife. It's like she's going along, I forgot, and turns into salt. Okay, so here's a picture. This is Spirit, and you can see the dust-covered solar panels. And here's where Lot's wife is. She's 2 inches tall. So, once they found out, oh, well, if those are Martians, we're not too concerned, but just a rock formation. Okay, the dust devils regularly go across certain parts of Mars, and they were used to clean the dust off the solar panels. I have one of Opportunity was located there, and they waited for the dust devil, and there was a before and after picture. It was pretty cool, and they were clean. Don't you wish we could have that come through our house and just get rid of the dust? And when they do go through, they leave these tracks. So the reddish sand is very shallow, and then there's dark soil underneath, or dirt. Looks like beautiful sand art. Here's Curiosity. Nuclear-powered 17 cameras, $2.5 billion. Our tax dollars at work. And here it is looking back at its tracks, February 2014. And notice how monotoned Mars is. It's different shades of beige. So now one of the challenges on the list of what the pioneers will have to face, one of them is called sensory deprivation or sensory boredom. They're recognizing that our eyes and our brains like to see contrast and colors, and we like some kind of variety. And there you can see. You're going to see that every day.
Is there a new lander? Did something just land on Mars again?
InSight. Yes, InSight. But it's not a robot, it's a lander. Yeah, and it's going to supposedly look for water beneath, and I think it's measuring the atmosphere, right? Does anybody, if you watch the landing, yeah. Oh, okay. Oh, that's okay. So on Mars right now is Curiosity. Opportunity might still be working. So that's like, 17 years? And now InSight. Okay, so here's Curiosity's mission. Determine landing site habitability, study climate and geology of Mars, and now it uses lasers and breaks up the rocks, and then collect data for manned mission to Mars. Now, the Humans to Mars Summit, you can go to the Humans H2 Mars website and read all about the sponsors. They have big money backing this up. In May 2013, NASA Chief Bolden and Buzz Aldrin met with CEOs of Google, Boeing, National Geographic, so many more, to discuss the plans to land on Mars by the 2030s. And I think it's Elon Musk that wants to not only go there, but he wants to die there. That's going to be his final trip. Okay, so here's the radiation exposure I was talking about earlier. The day after Curiosity landed, the radiation was measured for 3.5 hours. Okay, so it's made the trip, it's now on Mars, it's measured. So here's what this report said. Radiation levels measured on Mars during this period of quiet solar activity are reduced from the average radiation. So they're admitting that this is unusual. It's a reduced amount. Typically it's higher than what was detected in space during Curiosity's cruise to Mars. So the red arrows point to spikes in the radiation dose range, which would be the most dangerous to astronauts. And here we go. Every 26 minutes, you better be in your shelter, which means you have 13 minutes you can leave your shelter and you have 13 minutes to get back. You're not going to get much done, I think. Okay, here's the shelter. There's also a Dutch company that is signing up people, and they're going to do several years of training. So you've got NASA and this Dutch company kind of competing to colonize Mars. So NASA has decided hydrogen-rich material is very good at protecting us from galactic rays. So they're going to use ice. So you're living in 60 below or 100 below, and you're going to go home to an ice house. It doesn't even sound great. But anyway, the outer shell will reduce radiation exposure while allowing light to pass through walls, because they're finally taking in the psychological effect this will have on people. The insulation will be carbon dioxide to manage inside temperatures. Ladies, we will never have to shop again. We're all going to wear those outfits. And so no shopping, no comparison, no competition, right? We don't even have to ask, does this look okay? It's not going to matter. Here's the bot. It's IBO spraying a composite of water, fiber, and aerogel to create the walls. And this little creature, or this little bot, is also going to look for water in the dirt, pull it up in vapor form, and change it back to water form. And of course, it will freeze in the minus 60 degree temperature. This is going to be what you're going to eat. Right now, carrots and leafy greens have been the most successful, and they're going to grow them on the walls of your house, so you have a different color to look at. I know, you're all ready to sign up, right? I can see it in your eyes. You're so excited. Okay, water. 2016, this was probably the hottest topic about Mars, is finding water on Mars. So these dark streaks they appeared in spring and summer, but they faded in fall and winter. It was believed to be that these were evidence of seeping water coming out of this wall of a crater. Okay, you see the dark lines? And they were very excited. There seemed to be some hydrated salts, and they thought these salts were pulling up moisture from the ground, but it turns out they were not. So here's the test, 2016. Test for damp ground at Mars seasonal streaks finds none. Thermal imaging reveals an upper limit on how much water is present in these darkened streaks, about as much as in the driest desert sands on Earth. So there you go. So then, used a shallow radar instrument on the Utopia Planitia, and you might remember this headline: Mars ice deposit holds as much water as Lake Superior. I remember hearing people saying, did you know Lake Superior is on Mars? There is a lake that's that big. Okay, so here's the rest of the story. Analysis of, and this is the Mars ice deposit Planetary report, analysis of data revealed a deposit composed of 50 to 85%. That's a big difference. Water ice mixed with dust or larger rocky particles. Now, the sad thing is the Martian dust and soil contains high amounts of perchlorate, which is harmful to humans. It's toxic. It's used to make rocket propellant. So you could have 100% water and 1% poison, and we're still not going to drink it. So they're saying this is apparently good news. Remember, I warned you, don't sign up. Okay, so here's the plans to terraform. To terraform means to make Earth-like. They're going to change the atmosphere by melting the polar ice caps. There's a few ways to do that. Bomb the polar ice caps, or have a mirror that's suspended or revolving around Mars, and the sun's going to hit it and beam to the polar cap and melt it. When that happens, it will release carbon dioxide, is the belief. So now the land will be warmed, and then we're going to seed the soil and have trees and lakes, and then pretty soon ducks swimming in the lakes. Do we sound like we're God, right? Come, let us build ourselves a city and a tower whose top is in the heavens. Let us make a name for ourselves. Only God is God. He's the creator. And doesn't he emphasize that all through Scripture? He introduces himself as the creator at the beginning of the Bible, and then throughout, when a prophet's going to speak, it says, thus says the Lord, who made heaven and earth, or your creator. He emphasized, remember, I am the creator. Okay, Jupiter, named after the fake god of gods. For you, Lord, are high above all the earth. You are exalted above all gods. There is no other God. Okay, Jupiter has an ammonia atmosphere, radiation zone 20,000 times stronger than Earth, and extends 600 million miles. It is the second largest object after the sun's atmosphere in our solar system. And of course, Jupiter, we now have a camera called Juno that goes every 53 days. It takes a quick picture of Jupiter and moves away because this radiation zone will fry the electronics. Okay, here's one day on Jupiter is 10 hours. Those are called belts and zones. Belts are red, zones are white, and they travel different directions, different speeds. So, great red spot. We've seen that for about 300 years. And then, I think it was in 2012, the second spot came along. And of course, NASA does not have a creative naming department. And of course, this I tell the kids. So let NASA know what you would name these spots, because this is what they came up with. Red Spot Junior. And then, unfortunately, a new spot. And what else could they name it but new spot? So I tell the kids, send in your ideas. Okay, here's detailed image by Juno, reveal the spots have moved. So you see the great red spot, of course, you see that's the big one. And to the right of it is Junior, and new spot is to the left and below. But look at the details. I mean, the pictures from Juno are incredible. Look at those clouds. This was in 2017. And the white circles are believed to be cyclones. But it looks like more like art, doesn't it, than a photograph? It just shows the creativity of our God. I mean, he is the artist of the universe. Okay, here's the South Pole. Again, cyclones, and then these belts moving and whipping around. Just gorgeous. Here's Jupiter's southern aurora. It's an infrared, courtesy of Juno. Okay, here's Io. Now, when I see that, I think of pizza. I see mozzarella cheese. I see sun-dried tomatoes. I see black olives. Does anybody see those? We call this a pizza moon. The kids always remember Io because it looks like pizza. Now, Io does not have any craters, and there used to be a theory that the more craters a moon had, the older it was. But this moon and another one has done away with that theory. Over 400 volcanoes add to Jupiter's toxic atmosphere. Prometheus is a 50-mile high plume known as Old Faithful, and you see it at the top of Io. It has been active for at least 18 years. NASA scientists to Io, your volcanoes are in the wrong place. The unexpected eastward offset of the volcano locations is a clue something is missing in our understanding of Io, and that's where we want to be, saying we don't know. Let's do the science. Let's research and study more instead of, well, here's the theory, and we're going to arrange and tweak this to fit the theory. Let the evidence go to the truth. Okay, and here's Europa. Like Io, it has no impact craters. It's believed to be an ice-covered ocean. And when we look at it, we see material from beneath the crust rising to the surface and then surface material flowing back down. It also looks like ice road truckers, right? Kind of looks... Okay, so Comet Shoemaker-Levy was July 1994. It actually broke up, and it hit Jupiter, or Jupiter pulled it in. So Dr. Guillermo Gonzalez, he's a strong Christian astrobiologist. He believes Jupiter acts as a giant net between us and space, pulling asteroids in with its strong gravitational force. And on that, in that book, Privileged Planet, it has a list of what makes our planet habitable, and this is now one of them, is having a very large planet pulling in these objects coming in from space. So Jupiter's gravity is believed to keep the asteroids, because there's an asteroid belt between Mars and Jupiter, keep them close and moving, revealing purpose in placement. God doesn't do random. There's purpose. Here's Saturn, named after the fake god of harvest. one like the Son of Man, having on his head a gold crown, and in his hand a sharp sickle. And he that sat on the cloud thrust in his sickle, and the earth was harvested. Our God is the only one who is going to harvest the earth. Okay, Saturn, 75,000 miles in diameter without the rings, is a source of intense radio emissions. These clouds are revolving at 1,000 miles per hour. It also used to be believed, before we started sending cameras out there, orbiters, we thought we're going to see less energy the further from the sun the planets are. Instead, it grows. Okay, here's Saturn in ultraviolet. Now, Saturn is the least dense planet. It would actually float if we had a bathtub big enough to put it in. Guess which planet is the densest? It's obvious, right? Us, Earth. Earth is the densest. See, God has a sense of humor. Earth is the densest planet. Saturn is the least dense. Saturn in X-ray, we're not sure what those fluorescent lights are. And here it is in infrared. In infrared, of course, is heat, and you see no heat in the rings. Okay, Saturn's North Pole features hexagonal storm 20,000 miles wide with 200-mile-an-hour winds, and it maintains the hexagonal shape. Storm rotates at the same speed as the planet spins on its axis. So you can see the hexagonal shape stays as it's going around. Here's a hurricane in infrared on Saturn's North Pole. And now here's something that happened with that hexagon. The changing color baffles NASA scientists as they struggle to understand what caused the drastic changes in Saturn's surface. So it went from blue to gold from 2012 to 2016. So again, big change, little time. Okay, here's Saturn's rings, span 175,000. I don't know if this is going to go. Do I just hit it? Your thing? Oh, okay. Well, anyways, it sounds really cool. Oh, whoops. Yeah, the rings, we can hear them, and they kind of sound like a sci-fi. It goes, ooh, just what you would think if you're watching a science fiction movie. Okay, here's a close-up of the B ring. It reveals a corrugated-like texture. Look at them. They go up and down like this. And these are supposed to be rocks and ice. So we're going to look at them, and you tell me if they look like rocks and ice. Notice they're kind of by color. Isn't that interesting? And these are the mysterious spokes on Saturn's B ring. Will take years to understand per NASA. They don't know what they are. The Voyager 1 and 2 saw them, and they were black. And when Cassini got up there, they were white. But what are those shadows on the rings? When the sun set on Saturn's rings in August 2009, scientists on NASA's Cassini mission were watching closely. It was the equinox, when the sun illuminates the planet's enormous ring system edge on. The models correctly predicted how the rings cooled as they fell into darkness, except one large section, the outermost A ring, was much warmer than models predicted. This particular result is fascinating because it suggests the middle of Saturn's A ring may be much younger than the rest of the rings. She's a Cassini project scientist. For one thing, the rings of Saturn, here's another planetary scientist at the Arizona University. The rings of Saturn can't be more than a few 100 million years old at most, or they would have gone away. And here's a scientist, I think he's Croatian. I watched him on a SETI talk. For decades, researchers argued the rings must be much younger than Saturn because they should spread out in about 100 million years. So we've gone from 4.6 billion years to 100 million. That's a big leap. Infalling dust would have polluted them over billions of years, changing their pure icy condition. They would look dark and dirty. And so he's saying these rings have to be young. While a variety of features in Saturn's many rings display marked changes over multiple years, the F ring changes on a scale of days and even hours. Big changes, little time. Okay, here's Prometheus, and I'm not sure we're going to be able to see this one. Oh, it is. Oh, thank you, Lord. Okay, it looks like a flying potato. It's going up to bump up against the F ring, and then look what it's going to black out. Okay, now it's going to come back. Look what it's doing. Pulling part of that ring. Now, does that look like rocks and ice? Oh, it's working. Okay, so we're going to look, maybe. Anyways, on the inside will be that Prometheus, the one you saw pulling from the, maybe not. Anyways, it's pulling from the inside, and you'll see it just keeps, we'll try one more time. Nope. And then on the outside, you'll just see the stars going by. But it shows that as that moon pulls, other strands from the ring follow. And it looks like it's pulling all these strands. And that is the wake of what you just saw, that one moon grabbing that. What does that look like? Does it look like, what? Yeah. Doesn't it look more like water? And yet these are supposed to be some of the particles are as small as sand and rocks and ice. And yeah, it's got a different dynamic up there. Okay, Saturn's moons. And I love this guy. His Radwan Tajuddin, he's a Cornell research associate, and he's a member of the European-based Encelad scientific team. He said it takes one good spacecraft, he's referring to Cassini, to tell us how wrong we were in the past. Isn't that great? He has no problem admitting it. He said after 4.6 billion years, the moons would be much further away from Saturn due to their current migration rates. Some scientists estimate moons may be only 100 million years old. So now we got the moons are much younger, like the rings. Okay, Daphnis is a moon. We'll see if we can do this. Look on the left. Okay, there it goes. On the left, there's a little tiny moon, and those are waves, mile-high waves on the side. Imagine surfing those waves, and it won't matter if you fall down. And here is a visual simulation of that by Kevin Gill. He's a software engineer. So he figured out height, and he said that's what it looks like. So this moon is in this gap between the rings, and it's rippling them. And it just goes all the way around. It just keeps doing it. Okay, Enceladus, 314 miles across, looks like a golf ball. And Cassini noticed there were some geysers coming out of the South Pole and was told to go over there and taste it, and you've all tasted it. What do you think is coming out of this moon? Okay, here, I'll when you sit down to eat, you go, salt. Yes. And let's see if we can do. Anyways, that's another one with a sound that's very interesting. It almost sounds like it has a jazz note at the top. So it's so cool that everything has such different noises, sounds up there. Okay, backlit by the sun, Enceladus color-enhanced plume reveals its enormous extent. Those little geysers you saw, this is how far they go. And now, Cassini confirmed Enceladus's geysers created Saturn's E-ring. So we might feel unimportant, or what can I do? I like what Chris was saying about we all want to serve. And sometimes our own, chatter in our head says, oh, who's going to listen to you? Or, oh, you can never do that. And yet, look at the difference. This little moon changed this world. We can change our world. Here's Iapetus, this is Saturn's third largest moon with an orbit that is different from the other moons, and it's believed that dark substance on the one side it's sweeping up maybe what Enceladus is putting out. I mean, it seems to be there's some kind of something it's sweeping up. The others aren't. Here's Hyperion, resembles a sponge. Now remember, this is a gas giant planet. And look at all the different moons with different compositions, different shapes, and they came out of a gas giant. Here's Titan. It's the only moon with an atmosphere in our solar system. Here's the South Pole haze. That's natural colors. And it's believed that these are methane lakes. I'm sure these islands are going to go for real cheap. There's actually a belief that there's a lot of natural resources up here, and if we can only mine them. And I know, did anybody see that movie Prospect? It was just in Bellingham. It was made by two young men that grew up in Bellingham. Anyways, it's about mining moons. So they're keeping current with the plot line of mining alien moons. And of course, it has the usual one miner's up there with his daughter, another miner, wants to steal the daughter and take the mine or the whatever he mined pulled out of the ground. So yes, it's called Prospect. But this was a movie about the mining of alien moons. Okay, so we sent a probe. It landed on Titan, and look at the image. It looks just like a dry riverbed on Earth. You'd think it would be icy or just something weird. Look at that, could be here. Earth is seen from Saturn, 886 million miles away, and you see the lower picture, that dot. Without God, we are an insignificant speck. Carl Sagan called us a pale blue dot. I don't know if you remember that. He wrote a book and he said, no one is coming to help us. Like, we're on our own. Look how vulnerable and fragile we are from a distance, and that's it. And yet, with God, we are the greatest demonstration of his love, because we are small. Like Israel was the least. Earth is no big deal, and yet we are the apple of his eye. Here's Uranus, named after the fake god of the sky. Your love, O Lord, reaches to the heavens, your faithfulness to the skies. He reigns in the heavens. He rules in the heavens. He came down from heaven. He's coming back to take us to heaven. Okay, this planet is super interesting. It is our coldest planet. Now, Neptune is still further away, and this is colder. How does that work? It does not emit any heat. Jupiter, Saturn, and Neptune emit twice as much heat as they get from the sun. Twice as much. And this Uranus, this planet, emits nothing. Now, what's interesting is it's got a tilt. It's on its equator, and each pole faces the sun for 42 years. So it's 84 years is one revolution around the sun. And Voyager 2 found that the pole facing the sun is colder than the equator behind it. You'd think the pole facing the darkness for 42 years would be colder, and it's warmer. See? Different dynamics. And here's another thing. Uranus should not have a magnetic field, and yet it does. It requires a warmer core that has convection going up to the surface. It has none of that. It says the magnetic field source is unknown. We have no idea how it even has a magnetic field. The electrically conductive, superpressurized ocean of water and ammonia, once thought to lie between the core and the atmosphere, now appears to be non-existent. So we are completely baffled by this. Here's the spin axis of Uranus. So you see the spin axis is going, let's say, east to west. And then the magnetic field looks more north and south. Scientists thought these tilts would give Uranus a very strange magnetosphere. Guess what? The magnetosphere of Uranus is pretty much normal. And yet it doesn't fit the parameters that we understand. Okay, Neptune, named after the fake god of the sea. Then Jesus arose and rebuked the winds and the sea, and there was a great calm. But the men marveled, saying, what manner of man is this that even the winds and the sea obey him? Our God, the Creator, is who rules nature. Okay, Neptune's great dark spot. Notice great red spot on Jupiter, great dark spot on Neptune. It's the size of Earth. Our planet would fit in that dark spot. Winds reach up to 1,500 miles per hour, emits 2.6 times as much heat as it receives from the sun. Where does it get its energy? So what do the planets teach us about science? Okay, Mercury's liquid iron core, a young solar system. Venus advanced our knowledge of the solar system. Martian moons question lunar evolution theories. Jupiter's size and gravity reveals a purpose for its placement in our solar system. Saturn's rings and moon, big changes in little time, and they're much younger. Illogical magnetic field and polar temperatures. Are there different laws of physics outside of Earth? Are we that unique even within our solar system? And Neptune is furthest from sun, but has strongest winds. What is its energy source? Now this one, I'm just going to show you. We're not going to be able to turn these on, but there's 1,700 exoplanets. Exoplanets are planets orbiting a star outside of our solar system. So they're orbiting a star that's not our sun. And Ethan Cruz, he graduated from the U of W with an astronomy degree. He actually replicated their orbits and compared it to our solar system. And you see our solar system is on the right. And so our solar system, we have, the sun, and then the 4 rocky planets are just going around pretty slow and steady. And yet every exoplanet, it has, super Earth, mini Neptune, hot Jupiter. The gas giants of the exoplanets are as close or closer than Mercury is to our sun. In other words, it looks nothing like our solar system. And we expected our solar system to be the template for all other solar systems, And sure enough, we can't even find a similar planet like what we have. Rocky planets that are close to the sun and giants away from the sun, we can't find anything like it. Even our solar system itself is completely unique compared to other planets going around stars. And it used to be we would look at to see if the star had like a tug or there was a little part missing because the planet was going in front of it. But now the Spitzer telescope can actually see the atmosphere of these exoplanets and tell if it's like has a gas atmosphere or not. Okay, so what do the planets teach us about life in Jesus? Our word for planets comes from the Greek word planetes, which means wanderer. Ancient people were aware of planets, able to watch 5 move across the night sky with the naked eye, the same we see: Mercury, Venus, Mars, Jupiter, and Saturn. They called them wandering stars. In a warning about godless people, Jude used clouds without rain, trees without fruit, and wandering stars to describe them, to describe people that do not have God. Is God's word telling us when we choose not to surrender to Christ, we are like these barren planets in our solar system? So much potential and beauty and uniqueness on the outside, but utterly devoid of the life only our Creator can give. Because really, there has to be a reason we have these planets. God knew we were going to be studying them. We continue to send orbiters and rovers to other planets looking for evidence of life. But a first century spirit-inspired man, Jude, already knew they were empty. He's saying they represent empty people. If God's word has proven it speaks the truth about our physical world, wouldn't it also speak the truth about our spiritual world? If the Bible predicted scientific facts centuries before man knew them, it can predict signs of Christ's coming centuries before they happen. So we're left with a choice. Either the Bible is truth, inspired by a real personal God, or tales written by men. If truth, then we are left with the most important choice of all. What will you and I do about Jesus? And here in Deuteronomy, I have set before you life and death, blessings and curses. Now choose life. He's even saying, here's the choice, but choose the one where I get to spend eternity with you. What a God. Thank you. That's...
Well, we do have time for a few questions, so finishing up a little early.
Do I step down here? Come down here?
Yeah, sure.
Okay.
She has her mic, but if you have a question, just go ahead and raise your hand. And one question, please.
My question is, do you think that we're falling through space, or are we being ejected through space, or are we expanding through space? What do you think our motion in space is?
So are you thinking about...
Or are we floating in space?
Well, the whole thing with gravity and Einstein, and we're actually pushing, space is actually changing, and of course, because it changes, that's the rotation we have. To give you an idea, okay, so Earth is rotating around its axis about 1,070 miles per hour at the equator, and it's going around the sun at 67,000 miles per hour, and supposedly our solar system is traveling 490,000 miles per hour around the galaxy. So whatever the mechanism is that God has made, it works. I mean, even Newton said that, because of gravity, these things are in motion, but the harmony and the symmetry and the balance has to be from God. So for me, Einstein's theory makes sense that there's a bending of space, or he calls it space-time, bending of space as the planets go, but you know what? I'm not up there. I don't know. But I'm just saying it works, right? Yeah.
So we're a spiral galaxy?
Oh, okay, yes. We are, we're a spiral galaxy, and so we've got the arms going out, and we're at least one arm out from the center, because we can see the center, and there's an arm between us, and we're in the Orion arm. And, I had that, in the center, they believe that there's a black hole, but I believe Scripture says there is no such thing as black hole, but that's a whole nother presentation. Yeah. Oh.
Yeah, the instruments that you presented and all, what are the chances of scientists saying that we're 100% sure that the readings we're getting are accurate and not, Boeing just had an accident with a Lion Air where one of the sensors was not working
Oh.
properly. So all this stuff that they're seeing, how good do they feel that these are really accurate, like 100%, 50% accurate, or all this stuff that they're digesting? How accurate do they feel what
And you're
they're
talking
getting?
about the photographs or the actually like the
Any-
measuring the
anything,
radiation? Anything?
photographs,
Anything? Okay.
measurements, because it's human. There's one satellite that goes out there, and the chances are, yeah, it seems to be working. We're getting stuff, but how would you feel?
I will say this, if there was just one instrument up there and like one chance to get around the planet, yeah, I could question it. But there's a lot. I mean, there's a lot of countries now involved with taking pictures, and many are taken, or like an orbiter will go around and map the whole planet for a few years. So if it was off, I think we'd see it. Like there'd be good pictures and something wouldn't work, or the measurement of the magnetic field would not make sense. So from what I understand, it's repeated enough, and they have sent different quality of. I guess we just keep getting better with our technology. So I haven't heard that the higher quality has said that we were way off. I mean, I think we're off on what we believe what the evidence is. Yeah. But I think what we're seeing up there is pretty close. Yeah.
Last call for a question.
Lovely lady in the back.
Hi. How do they know what the chemical makeup is on
mean
like the planets so far out that we haven't gotten? I mean,
Oh,
we've
soil?
gotten actual chemical readings from all these planets, or is it just
The composition
speculation?
of them.
Yeah.
Yeah, that's a great question. I know that the planetary formation model is that there was a cooling sun, and it was ejecting rocks that started merging together and became planets. But they would all have the same composition. So you're right. How do they know what the composition is of like Pluto or Neptune? Now, see, you have two gas giants, two ice giants. We don't know about their core. We haven't sent something down that has seen land down there. So really, it's Mars would be the furthest one that we've done the composition, and we have robots there zapping rocks, and so we do know that. Venus, we've had some landers. Russia had a few landers, but they think they melted in an hour. So, because that's, Venus. But yeah, so Mars we would know because we have something that's taken a reading. Mercury, Chris, is there something they can... Yeah, I wonder if there's filters. Sometimes there's filters, but I don't know. To me, it's like you'd have to be there, boots on the ground, and looking.
Spectrum analysis that can tell from the light.
From the light, okay,
Spread the light out to the spikes.
sure.
Different elements,
Okay, he's saying there's a spectrometer, right, that you can see. Okay.
the different elements.
Oh, the elements, okay. Okay, the elements have different colors. Okay, great. But yeah, I like the idea of chopping them up and looking at, yeah.
Any other questions?
Oh.
No?
Okay.
No, please.
What happened to Pluto? I know nothing about Pluto.
Pluto, okay, well, we sent New Horizon was what we sent up there to take some really close-up pictures, and the man who discovered him, his remains were on board. So his family was, they thought that is what he would wanted. Okay, I have pictures of Pluto. It has mountains that look like they're made of ice. It has some very different terrain. Charon, the moon, there's something very unique about that. And there was, I think, 4 other moons. There's multiple moons. Earth is the only one that we have that one moon, and the proportion between moon and planet, we're the only ones like that. But Pluto had some very unique terrain, and it also had, I have a quote from an astronomer that was on the Pluto program saying, the moons are so much younger, I wonder if we took a closer look, because they only just sent New Horizons, not spending a lot of money like they are on Mars. And so she said, I wonder if we could take a longer look or more in-depth look and see what else is young about Pluto. So I do have that quote, but yeah, it was pretty interesting. And they think we're going to be learning for years, because it takes time to send back the pictures. Yeah.
Awesome, Maureen. Thank you a
Pretty cool.
bunch. That was awesome.
Thank you.
So amazing, right? All right, so let me remind everyone that I'll be doing a talk next week on the wonders of the human body. So just the incredible biological design there we see within the human body. And then, and I remember the reason why I had a date set up for like January 30th is because the second week in January, there is no program. There's a special church event. I don't remember exactly what it was, but they're canceling all the classes that weekend. So anyway, but we got some interesting speakers coming up. Patrick Nuri is going to be here in January, and then we got a speaker from Answers in Genesis going to be here in February. So some things to look forward to. So would you close out in a word of prayer?
You bet. Sovereign God, Creator Jesus, Lord, thank you so much for being with us. We come here to learn more about you, Lord, to learn more about your character, to love you, serve you, to be more like you, Lord. We know you're changing us from the inside out, and we are just amazed that you love us like you do, and you want us to live with you forever. And Lord, we all see the evidence that you created it. It was spontaneous, direct creation, Lord. And just give us the courage to keep witnessing to people in that loving way, that to tell them about your power and your glory, and just, Lord, what an amazing God you are. Again, thank you for everyone here this evening. Please bless them as they go home tonight. In your name, amen.